Hello everyone, I am Arun Kushwaha, and today we are going to discuss about the second part which I have promised that I will cover up, that is types of transformer. In previous video I have discussed about the transformer. What is a transformer? But in this video I will be discussing about types of transformer. So be with me and watch this video, okay? Here the there are two types of mainly transformer used. One is step up and second one is step down transformer. In step up transformer we can see in diagram that input voltage and input voltage of AC means alternating current is being given to the primary coil. Which coil? Primary coil. And the primary coil receives the input voltage, and here the current passes and the flux generates like this and this. Through that, an EMF current induced in the secondary coil, that is output coil, here in this part here, and here also the magnetic flux increases like this and like this. Now we get output at the secondary coil output here, okay, and we can see that the number of turns on the primary is less and number of turns on secondary is more. So we can say that it is a step up transformer, because in a step up transformer the primary has less number of turns and the secondary has large number of turns. And we can see that here the material which is taken, it is a iron core which is soft. It is not mentioned, but it is a soft iron core, okay. And the soft iron cores are laminated. What is laminated? The each core is laminated with a material so that they cannot be in contact with each other, okay. Now we move ahead and we see that the output voltage which is obtained, that is also in alternating current AC, okay. Now we'll move down. The transformer used to change the low voltage alternating EMF to high voltage alternating EMF of same frequency. Here remember that it is given of same frequency. Frequency doesn't vary. It will be what we will be giving in input. Here in input the frequency means 50 hertz. If we will give, then we will get 50 hertz. Frequency doesn't remains changed, it is unchanged, it is same, means to say. And here the once again I repeat the sentence. The transformer used to change the low voltage, that is change low voltage alternating EMF, the current or EMF voltage that is given to it on primary, it converts low voltage to high voltage, means low to high. Only one thing you have to remember, and here frequency doesn't change, then it is called step up transformer, okay. Now move. In a step up transformer, the number of turns in the secondary coil are more than the number of turns in primary coil. In a step up transformer, the number of turns on the secondary coil are more than the number of turns on primary coil. We can see that the in the figure, I will be taking you to the figure that in primary coil the number of turns are less, and here secondary it is more. That's all it's saying. So we can classify that it's a step up transformer due to large number of turns on secondary coil. Now here that NS by NP, mostly we want to know that what is NS by NP. I'll be telling you in detail that NS is number of turns on coil, secondary coil, and NP is number of turns on primary, P for primary coil, okay, and it is greater than 1, which is greater than 1. Okay, that is ns by np is greater than 1, means the value of 1 will be always greater than ns by np ratio for only step up transformer. Now in case of the step up transformer, ns is greater than np. What is ns is greater than np? Okay, matlab ns number of turns on primary, number of turns on secondary is greater than number of turns on primary. Number of turns on secondary is greater than number of turns on primary. We can see on primary it's less turn, and in secondary there are number of turns. Okay, here it is depicting that np is less than ns, yeah, फिर ns is less than np in a step up transformer. Therefore es is greater than ep. Es means secondary emf, and ep is primary emf. Here now I will be taking you here the given emf, which is input, which is called an input emf, and it is called output emf. Okay, now come to the point. Therefore es is greater than ap. Secondary emf is greater than primary emf. Okay, but is, that are different thing. But now emf secondary is greater than primary, and is means current on secondary coil is greater less than current in primary coil. Okay, remember that is more current flow in primary coil. The number of currents means more current flown in primary coil, and so one must use thicker wire. One must use thicker wire in primary coil as compared to secondary coil. In primary coil, we can use thicker wire in primary coil as compared to secondary coil. Okay, step up transformer. Now we will be discussing about the step of transformer. Here the figure is about the step of transformer. Okay, here I have forgot to tell you that this is a step down, it's a transformer, and this is a power plant. Here is a power plant, and after that it gives power 12 kilowatt to step up transformer. Here is step up transformer, and then it is supplied through the wire to high voltage transmission cable to the step down transformer, which is substation, known as the substation. Now it is then supplied through 13 kilowatt wire and pole to the step down transformer, which reduces its voltage or emf, we can say, and then it is taken to the household supply, which is 240 volt, 240 volts, and its frequency is 50 hertz. And this supply which comes in our house is known as household supply, or we can say that it's a 240 volt 50 hertz frequency supply, and we get it. Okay, now come to step down transformer. A step down transformer, the transformer used to change the high voltage alternating emf to low voltage alternating emf. High voltage alternating emf to low voltage alternating emf, bus, that's all. High voltage, if we give high voltage emf, it will be giving low alternating emf. Which alternating, I'll be discussing about the emf in the next video. What is an emf? It's an electromotive force. I will be discussing it in separate videos so that you may understand well. And here also the same frequency will be not changing, it will be same, which is called step down transformer. Means we will be giving more and taking low. Step down transformer, here the figure is that we are giving we are giving 1000 volt and 2 ampere to the primary, okay, and it has 2000 watt power, and it has 50 tons. We see that here 50 tons are there, and it through this passing current on secondary coil, the induction occurs, and here the number of turns are 10 turns. Here more turns, here more turns, and here less turns. Now the given output we will be getting is 200 volt. 200 volt as compared to 1000 volt means the volt decreased, okay, and the ampere 2 ampere, here 2 ampere was there, 2 ampere to 10 ampere means the current has increased, voltage has decreased, voltage has decreased, current has increased, and the power is same, so the frequency will be same, that is same frequency, okay. And here the EMF that will be given on the EMF that will be given on the primary will be greater than the secondary, means if we give more EMF at primary, we will get less EMF at secondary. Here number of turns are more, and here number of turns are less, so from more to less it is down, going down, so it is given as name step down transformer. In a step down transformer, the number of turns on the secondary coil are less than the number of turns on primary coil. In step down transformer, number of turns on secondary coil, जो number of turns होते हैं secondary coil में, that are less than number of turns on primary coil, which I have taught you earlier, okay. Here now the ratio, the important thing is you must know the ratio. Here ns by np means number of turns on secondary is to the number of turns on primary. Here this primary and this is secondary, this is primary and this is primary and this is secondary, and we can say that ns number of turns on secondary to the number of turns on primary. Here to this in physics term or in definition term, to divide को हम लिखते हैं to the, that is if I want to say it in a definition word, then we can say that ns, the ratio of ns to the, see, to the, this one which middle slash I am telling, this one, इसको हम कहते हैं to the, and we can make that ratio of number of turns on primary, number of turns on secondary to the number of turns on primary is less than 1. The value ratio will be less than 1, not greater than or equal to 1. So we can know that it's a step down transformer. Here ns, here we got that np is greater than ns. How? Here I am showing you ns by np is less than 1. We will take it to the cross multiplication. Through cross multiplication we move it to here, then we will be getting, 1 minute, ns is less than np. Now you will be little bit confused, sorry 1 minute, ns is less than np. Here one thing will be confused, that it is giving np is greater than ns, same thing but it has changed, altered. If we alter, then we will get, keep it here np, then the sign of the greater will be here and it is ns, so we can see that it's like this, okay. Now move to the primary. Here the diagram is given of the transformer. this has primary which has more number of turns, it is secondary less number of turns. Means number of turns on primary, this is number of turns on primary is greater than number of turns on secondary in case of step up transform, step down transformer, sorry. Here the thing, this is showing that induction, due to induction this is showing like this or this, okay, don't be confused. Now move here. Now we talk about the EMF, the voltage or EMF which is supplying to the transformer in step down. We will be EMF of primary coil will be greater. Here the primary coil EMF will be greater than the, and the secondary coil EMF is lesser. Why? Because step down transformer, here more, here it is more, and here it is less, okay. And IP is less than IS, means current on primary is less than the current on secondary, means primary has less number of currents and secondary has more number of current, which I have taught you here. The current 2 ampere, primary has less number of current, more less number of currents, and secondary has more number of current, okay. Now come here, the secondary winding will require thicker wire due to current. Now we can see that the secondary winding will require thicker wire. This secondary winding require thick wire due to high current, because we'll be uh, getting high current at the second point. The use of thicker wire reduces the resistance. See that thicker wire reduces the resistance and therefore reduces the loss of energy. If we use thicker wire, then we will be getting less resistance, and if resistance will be less, then the energy loss, which is known as hysteresis loss, we will be studying in next higher classes, that hysteresis loss of the energy as a heat in the coil will be less. One thing I have forgot to tell you, that come I'll be showing in transformers, any transformer step or step down, the current that are passing given and that we will be taking it out. Here the process goes, or mean process या फिर processing. If we will be giving input, means if we are giving input 100%, 100%, okay, then in processing work, the heat, it will be, the machine parts will be work while working, they will be giving heat. We can see near transformer standing, we can see that it gives out heat, exothermic, means they used to give heat. And I want to say that these, what you are giving the input, that is 100%, the output that is after processed we will be getting, that will not be 100%, that will be 70, 80, 90, 99, but not 100%, because it is impossible to get 100%. So we can say that the machines are not ideal, not ideal. Case of ideal is that ideal machine are that which if we give 100% energy, then we will be getting 100%, which is not possible, okay. Here in universe it is not possible. In processing, some energy is required as a heat or anything else, okay. Heat, sound. Now come to the last point, what we were there in this figure were loss of energy, okay. The energy loss due to heat is known as copper loss. What the energy lost is known as copper loss. Which loss? Copper loss. Here the figure of the step down transformer is given here, okay. The next topic I'll be teaching you all about the energy losses in transformer, okay. Thanks. Like and subscribe, guys. Likes and subscribe if वीडियो इज़, इफ़ यू लाइक दी वीडियो, ओके। आपको वीडियो अच्छा लगे तो लाइक और सब्सक्राइब कर दें। Okay, thanks.